By the end of this video, you'll have gone through your first introduction to doing a fluid model. We'll do it using SolidWorks, just like when we started doing solid modeling with FEA. We'll start doing the first fluid model using SolidWorks basically because it's a little faster and easier to get started. You'll find that it's quite limited by comparison to what you can ultimately do in ANSYS, even more so than you may be encountered with the solid mechanics modeling. So let's get started. So I've just got a blank SolidWorks model here, and I'm going to quickly make up a just a random pipe model that we can play with. There. Now we have a really simple model. I've got a pipe draining out of a big tank with this weird vein in the middle. So as you can see, it's not symmetrical. If I hadn't put the vein in the middle, then the sensible way to model this would have been to rely on symmetry and do just a pie slice. But we can't really do a pie slice here because it won't be representative of anything that's going on, given that there really is no symmetry that we can take advantage of. So with that, we can go to SolidWorks add-ins, and you should be able to put the add-in of flow simulation in. If this isn't available to you, then you'll have to go back to your licensing tool and install the SolidWorks flow simulation tool, just as you may have done with the SolidWorks simulation. Now, the thing is, nothing here is a fluid. So ANSYS SolidWorks doesn't know that we're doing a fluid analysis because there is no fluid set up here. So the first thing we want to do is to create a fluid volume somehow. The easiest way to do this is to use the wizard. You can also do it in the analysis preparation by creating new surfaces. But we won't do that at the moment. We'll take advantage of the easy way, which is the wizard. And the wizard opens up, and the first thing it wants us to do is give the project a name, which I'm calling Fluid Model 1. And we can select the units, which is fine. We're happy with the SI units we're working in. Now we want to specify whether it's an internal flow or an external flow. Both can be handled, but they're different. So let's ignore gravity or any of these things at the moment. And let's choose an internal flow. Now, I want to use a liquid, and so I'm going to look for water. I'm going to add water to my project. The walls of my vessel, I'm going to just assume that they're smooth for the moment, but I could add a roughness here, but I just won't. So now it doesn't know what our fluid region is, so we have to select planar faces that belong to the opening. That's a planar face. And that's a planar face. So what our model has done is create lids. And you can see here, we've got a lid there. We could have done this by creating surfaces in the solid part, but the flow model tool recognizes that we're doing this. Now, because we're going to have to select internal surfaces, I'm just going to change the viewport so that I can see hidden lines here. So we have a capped region. Now, all we need to do is specify some boundary conditions. So we go up here to boundary conditions, and I'm going to choose a face. Now, I want to make sure that I choose the right face. And so if I right click, then I can see which face I'm actually looking at. Do I want the face on the lid itself? I think I'll just take that face on the lid. And that's going to be an inlet velocity. And I'm going to make that very small. I'm going to make that velocity 0.001 meters per second. The reason that's so slow is because clearly there's a big volume change. And you can see that it's shown the arrows of my ways. Now I need to add another boundary condition, which would be once again selecting right click to make sure I pick the right face. I want the face of that lid. I'm not sure that that's the right one. There, I want that face of lid 2. There we go. And so far I found that that is the most annoying part of this, is making sure that you get the right boundary conditions. Now we can move ahead now that we've specified those boundaries, and so we can check that and see that, yes, that is the right fluid volume that we want to model. And so it looks like our analysis types and everything look to be okay. So we can specify goals in terms of what we would consider to be a suitable solution. And we can just try to run this. Now, it's going to solve a new calculation. And let's give it a try. And you can see here that it's going through, as I said in the previous video, iterations. And this will go up to a number of iterations until some standard conditions have been met. So the solution is complete. And now we can look at some plots. So that was the first really rough flow model. Now, one of the things that we didn't do is any reality check. Certainly that's essential. So I created a model that had water flow in one end and out a pipe on the other. I didn't include gravity, so that would need to be done in an updated model. I didn't include a free surface, so this wasn't like an empty tank. And I really need to look at those values of velocities and pressures more closely and do back of the envelope calculation to just validate whether or not the solutions were even remotely realistic. That's an essential part of the job of modeling of flow systems.